Hey guys, in this lesson we're looking at classifying triangles and classifying triangles in the coordinate plane. So to start off with, classifying triangles just means taking a triangle and putting it into a group or giving it a name based on either the measure of its sides or the measures of its angles. So we can be looking at a triangle and just based on the information that they have about the angles, we could put it into one group or another. So to start off with, we'll start by classifying by angles. And when you're classifying by angles, you're going to put that triangle into the group or give it a name based on the measures of its angles. And the three that we're looking at is acute, obtuse, equiangular, or a right triangle. So when you're looking at an acute triangle, you're going to have all of the angles in that triangle is going to be less than 90 degrees. So you'll just be given a triangle and it'll just be very obvious that all of them are less than 90 degrees. And they don't have to be the same, they can all be different just as long as they're less than 90. So to show that they're different, I'm going to put different angle measures in there. And I'm not going to use a 90 angle degree mark because they're not 90 degrees. So looking at an obtuse triangle has one angle that's greater than 90 degrees. And you're just going to have one angle that's obviously a lot bigger than the other two. And it's going to be the same way in a coordinate plane for both acute and obtuse. The angles are going to be less than 90 or greater than one angle greater than 90. So then we're looking at equiangular. And if you look in there, you see the word equa. That's kind of like the word equal. And that'll be the hint for all the angles are equal. So equa meaning equal, angular meaning angles. So an equiangular triangle, or all the angles are equal. And if you do the math for that, that comes out to they're all going to be equal to 60 degrees. So one way that you could see the triangle be drawn is it'll look like that. And then in the coordinate plane, the way you know that you have an equiangular triangle is you'll find all the sides, and all of the sides will be exactly the same. The last way you could classify triangles by their angles is a right triangle, and you're going to have one angle that equals 90 degrees. So in pictures, if they don't give you the 90-degree measure, they'll give you that little box to tell you 90 degrees. And the way you tell that you have a right triangle in a coordinate plane is you're going to have two sides of the triangle are going to be perpendicular. So if you remember, the way that you tell two sides are perpendicular, they're going to be opposite reciprocals. And you would have to check out the slopes for all three lines. Or sides on your triangle. And if you can either count your slope, or you can use your slope formula. Slope is going to be equal to y2 minus y1 over x2 minus x1. So that's what you do to classify by angles. Looking at classifying by sides, you're going to put the triangle into a group or give it a name based on the measure of its sides. And they can be scalene, isosceles, or equilateral. When you're looking at a scalene triangle, in a picture, all the sides are going to be different lengths. And then another hint will be all angles are different. So in a picture, they'd give 1 tick mark, 2 tick marks, and then 3 tick marks. And that's how you tell they give you, or they could give you side measures. And then how you find a scalene triangle in a coordinate plane, you're going to use the distance formula, and all the distances are going to be different. And if you remember, distance formula is going to be equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So looking at an isosceles triangle is going to have two sides that are the same length. So looking at a picture, they could give you something that looks like this. They could also give you actual measures. And you could also have two angles that are the same measure as well to have an isosceles triangle. And then for the coordinate plane, using a distance formula, you're going to find two distances. After you do all three sides of the triangle, you're going to find two distances are exactly the same. And then the last type you could have is an equilateral triangle. Again, you see the word equa, meaning equal, and lateral means sides. So all the sides are going to be equal. They could also show you all angles are equal. That would look like that. And they could also give you side lengths. And then again, in a coordinate plane, you do the distance formula for all three sides, and you would find that all three distances are going to be exactly the same. So looking at our example, it says classify the triangles by angles and sides. And if you remember, angles, it can be acute, obtuse, equiangular, and then right. So each triangle is going to be one of those four things. And then by sides, it could be scalene, isosceles, or equilateral. So we've got to have one of these for angles and one of those for sides for our answer. So if we're looking at this, we've got 4, 4, and 3. So we've got two sides that are exactly the same, and we've got two sides that are exactly the same. That's going to be isosceles. And then looking at all the angles are less than 90 degrees. So it's going to be an acute isosceles triangle. Then looking at the next one, all of the sides are going to be equal. So if all the sides are going to be equal, that's going to be equilateral. And if we have an equilateral triangle, we automatically have an equiangular triangle. Looking at the next one, they gave us angle measures. So we've got 28, 55, and 97. So if we're looking at our definitions, we've got an acute triangle. Acute says all the angles have to be less than 90 degrees. Well, it fits except for 97. So 97 is not less than 90, so it can't be acute. So then we're looking at obtuse. Obtuse says we have one angle that's greater than 90. So if we look, there's our one angle that's greater than 90. So we've got an obtuse triangle. And then we need to classify based on the sides. So looking at the sides, all of these talk about side lengths. The first part that aren't in parentheses, those all talk about side lengths. But if you look, all they did was give us angles. So in parentheses, I've given you hints as to how if they only give you angles, how to name them based on their sides. So if you look, all the angles are different, two the angles the same, all the angles are equal. Well, all the angles here are different, so we're going to have an obtuse scalene triangle. Looking at the next one, they've got one arc mark here, one arc mark here. That means we have two angles that are the same, and then we've got this one right here. So if we're looking at our definitions and we're naming by angles, it says all of the angles less than 90 degrees. Well, they're not small and less than 90. And a good way to measure 90, if you're not sure, an edge of a paper is 90 degrees. So if you take a piece of paper and you've got an angle that's more than that, that's not going to be an acute triangle. So then looking at the next one, an obtuse triangle, one angle is greater than 90 degrees. Well, that definitely happened there. So this one's going to be obtuse. So there's by angles. We still need sides. So if we look at our list for sides, and if we look at our picture didn't give us any side lengths at all. So we've got to go by what the angles are telling us. So if we look, it says all the angles are different. And if we look, those two are going to be the exact same because they have one arc mark. So two angles being exactly the same is going to be an isosceles triangle. So that triangle is going to be an obtuse isosceles triangle. And then looking at the last one, we've got one arc mark there, two there, and a box right there. So if we're naming by angles, this box right here means we have a right triangle. So it's going to be right. And then naming by the sides, they didn't give us any information on the sides, so we've got to go by what the angles tell us. This one is all the angles are different because we all have different arc marks there. So this one's going to be a right scalene triangle. Looking at the next example, it says we have a triangle having angle measurements of 62, 56, and 62. And if we classify by our angles, an acute triangle is all angles less than 90 degrees. Well, that fits. Just to double check, obtuse, one angle greater than 90? No, they're not all 60, and they're not, one of them is not 90 degrees, so it's going to be an acute triangle. And then we've got to qualify or classify it based on its sides. So because they only listed us angles, we've got to check the angle part of the definition. So all the angles are different. They're not, we have two that are the same. So two angles that are the same is going to be isosceles. So we have an acute isosceles triangle. And then looking at the last one, a triangle has side lengths of 8, 13, and 9, and this one says just classify by the sides. So if we're looking at classifying by the sides, it says all sides are different lengths for the first one, and that's what we have. We've got 8, 13, and 9. Those are all three different numbers, so this is going to be a scalene triangle. And we would need more information in order to be able to classify it by angles, and that's why we didn't classify it by angles. So these gives you some basic, if you're shown a triangle and you're given either the side lengths or angle measures or just the arc marks or tick marks, how you can classify those triangles.